So we come to the invasion of Hastings, or 100 years after that. This is now 1166, and we're going to speak once more about the mildly interesting Henry Stapp, to use an under exaggeration, if there even is such a word. Henry Stapp was in close contact to many famous scientists of his time, and earlier on, Heisenberg acknowledged his ideas before he died and thought them to be very interesting and compelling. And I think that's important because the conservatism that the first pioneers of quantum mechanics did uphold most of their lives is what Henry Stapp is referring to or building on. That conservatism, what Henry Stapp calls the orthodox interpretation of quantum mechanics, was diluted for good reasons, for practical reasons, and for reasons of understanding, until quantum mechanics today is a variety of ordinary physics, and not in stark contrast or anything like that. Well, we know that to be not the case in reality. It's still the question of how to transfer this to the public. Last I was talking about the two processes, and continue on page 9. The two phases of process 1 are manifested of the differing points of view of Heisenberg and Dirac, cited by Bohr, in which Heisenberg emphasized the free choice of the part of the experimenter of which probing experiment to perform, while Dirac emphasized the choice of the part of nature regarding which outcome occurs. The whole process resembles, as emphasized by Wheeler, the game of 20 questions, in which a succession of yes and no questions is posed, with each eliciting yes or a no response. Von Neumann cast into rigorous mathematical form the key ideas of the founders, insofar as they strayed from the official pragmatic path and tried, as scientists rightfully do, to understand what is really going on. The fact that the generation of a conscious perception involves a dynamical process that is structurally and mathematically extremely different from the deterministic, matter-driven process that governs the unobserved evolution of reality, is the basic difference between materialistic classical mechanics and its quantum successor. The classical theory presumes that all aspects of nature can be explained purely in terms of the action of matter upon matter. But the quantum world differs in a fundamental way from that core precept of materialism. This huge structural difference in the real, i.e. quantum world, between the matter-matter interaction and the matter-mind interaction makes manifest the extreme naivety of trying to comprehend the connection between mind and matter within a materialistic framework. In the quantum world, the observing processes of acquiring empirical knowledge must disturb or perhaps even bring to existence the values that we observe by virtue of Heisenberg's discovery. The process of acquiring knowledge injects our mental aspects in an essential way into the process that determines what we will find if we look. This non-materialistic action injects the mind of the observer as a causal agent into realistically interpreted orthodox quantum mechanics. It gives our minds an essential dynamical role to play, hence a natural and rational reason for them to exist. Is in this game of 20 questions, the yes answer is the occurrence of some particular perception, say P. So the question must in principle be whether the upcoming experience will be P. The question is thus a non-verbalized inquiry of the form, will my upcoming perception be P? Where P is a felt experience representation of a particular possible next perception. This query is instantly followed by nature's response, yes or no. This two-phase process allows our human conscious choices to enter causally into the evolution of the matter-based aspects of the world, rather than being helpless witnesses of a flow of events completely determined by the material aspects of nature alone. Well, it is impossible to have classical physics without the idea of taking away the observer. It is its second mission, its hidden agenda, so to speak. Our probing actions and the observed outcomes are described in terms of potential and actual perceptions, respectively. According to the orthodox theory, these perceptions are described in the language, conceptual structure of classical physics. In orthodox quantum theory, the disparate perceptual and associated material properties are causally tied together by the quantum dynamical laws that govern the mutual interaction. Mind is dynamically tied to matter, but it is neither made of matter nor dynamically predetermined by matter. This should be compared to Eintwurft, thrown into the world. And since we always have been thrown into the world, we cannot feel that we have a free choice. Or we might not feel that we have a free choice. Because what we are is determining the outcome, and also the idea or the misunderstanding that we haven't always been in this world will make it for us seem like everything happened by itself. Our personal conscious thoughts enter the quantum dynamics via these abrupt process one actions. Our human minds instigate probing actions upon the quantum atomic particle based material world that is evolving in accordance with process 2 I mentioned in the previous lecture. Each such process 1 intervention is in line with the ideas of Heisenberg, Dirac Wheeler and Whitehead, resolved by a two-phased action. The first phase is a probing action, which poses a yes or no query about the observer's upcoming perceptual experience. The choices of these probing actions are, according to the precepts of quantum mechanics, not fully determined by the prior material properties of the atom-based world. They instead originate in association with the observer's mind, which von Neumann calls the observer's ego. These choices are free in the very specific sense that they are not determined by the prior quantum mechanical state of the universe. They are therefore called free choices. This injection of an element of freedom from material coercion constitutes a major departure in quantum mechanics from classical mechanics and from the general philosophical stance of materialism, which demands that the evolution of matter be fully determined by material properties alone. The second phase of process 1 is an immediate yes or no response on the part of what the British physicist Paul Dirac, a key founder of quantum mechanics, called nature. A positive yes Sorry. A positive yes response adds the perception P, which was specified by the observer's query, to the observer stream of conscious perceptual experiences. It also instantaneously reduces, that is, collapses, the global quantum state of the universe to the part of its immediately prior form that is compatible with that positive response. A negative response leaves the observer stream of consciousness unaffected. No perception occurs, but it reduces the global quantum state of the universe to a form compatible with that negative response. Nature responds sequentially to the probing yes/no question posed by the various observers. But how is the needed connection established between a person's mental choices or probing actions and the intended bodily response? It can be assumed that the observer's ego creates, by trial and error learning, beginning in the womb, a mapping of the perceived response to each of various mentally instigated probing actions. Thus, the ego's knowledge of which effort tends to lead to which perceptual feedback can be learned. It need not to be innate. In mathematical that's complicated, I won't mention that. I have included this parenthetical mathematical remark merely to assure readers that the ordinary words that I have been using are not mere verbal fluff. They have definite mathematical meanings, which lead to predictions that are accurate, in one highly non-trivial case, to the width of a human hair, compared to the distance to the moon, that encompass in general a vast realm of pertinent empirical phenomena. Quantum theory thus warrants serious consideration by any reader truly interested in the basic nature of things. Any adequate proposed alternative to the orthodox interpretation needs to produce a theory of the mind-brain connection that is as good or better than the orthodox theory described here. For our experiences are the only things we know, and hence their empirical structures needs to be explained by any basic physical theory that can be deemed satisfactory. The action of mind on matter. The entry of the abrupt process 1 actions into the continuous process 2 evolution entails that the mind of an observer is no longer a helpless witness to a mechanically predetermined course of material events. The process 1 actions convert the observer's ego into an actor on the world stage. Each probing action initiated by an ego influences by means of nature's response to that action the macroscopic behavior of the atomic particle-based material universe. Thus our minds become endowed by means of the quantum mechanical dynamical rules with the power to influence the macroscopic properties of matter, without themselves being totally predetermined by material properties alone. This empowerment of our psychological aspects is a fundamental feature of standard quantum mechanics. This change in the basic ontological structures eliminates by means of an advance in science the absurdity of consciousness that can do nothing but delude us into believing an outright lie, that our minds are causally inert, which, if believed, would surely be detrimental to the ambitions of anyone who accepts as veridical the findings of science. For an acceptance of the belief in the total physical impotence of one's conscious efforts would seriously undermine the mental resolve needed to overcome the obstacles that often stand in the way of our efforts to create what we judge to be a better world. The empowering message of quantum mechanics is that the empirical data of everyday life and also our intuitions are generally veridical, not delusional, and hence that our mental results can often help bring causally to pass the bodily actions that we mentally intend. The role of our minds is to help us, not to deceive us, Sabine Hossenfelder, as the materialist philosophy must effectively maintain. and it must it also. That's very important. It's a must. It is not as if they could do otherwise. Very important, they have to do it. Appearances are deceiving. Classical appearances versus quantum realities. According to the quantum rules described above, each true perception is an experience of certain macroscopic features of the material. That is atomic particle-based universe. This means that according to quantum theory, each perception P is described in terms of macroscopic properties of systems built basically out of the solid, massy, hard, impenetrable, movable particles of Isaac Newton. That world of perceivable macroscopic properties can be called the world of appearances. On the other hand, quantum mechanics also describes the macroscopic properties of macroscopic systems built out of the atomic particles of atomic physics. From the point of view of realistically interpreted orthodox quantum mechanics, the underlying physically described reality is the quantum state of the universe, and it is built out of quantum mechanically represented atomic particles and their associated physical fields, whereas the appearances, perceptions, are built out of Newtonian particles. But this means that in quantum mechanics, both the physical reality and the appearances are represented mathematically. This mathematical duality provides the foundation for a greater role of mathematical and logical rigor than was possible in the classical physics-based materialistic approach. There, the underlying physical reality is deemed to be built out of the fictitious Newtonian particles, yes, instead of the contemporary science-based atomic particles. And the appearances are described in psychological terms. Hence, the quantum mechanical approach to the mind-brain problem is structurally and mathematically very different from the classical materialistic approach. And because both our perceptions and the underlying material causal structure are described mathematically, it provides for greater mathematical and logical rigor than classical physics allows. These two physical theories, classical and quantum, are contradictory. Yet orthodox quantum mechanics combines them to produce a rationally coherent understanding of the connection between mind and brain. This quantum approach constitutes a way of comprehending that connection that is far more reasonable than what is attainable within the materialistic framework, which is fatally flawed by the omission of our causal minds from the theory of the mind-brain connection. It is like Hamlet without the Prince of Denmark. The often heard claim that quantum mechanics is not relevant to the mind-brain problem because quantum theory is only about tiny things, is absolutely contrary to the basic quantum principles. Being big does not tend to make a quantum system truly classical. Quantum mechanics is explicitly designed to cover big systems, but by becoming big, a quantum system does not become classical. Very important. But becoming big, a quantum system does not become classical. Indeed, the fact that quantum mechanics is explicitly designed to cover big things is important to the solution of the mind-brain problem. For the quantum mechanical dynamics leads to the evolution of the brain via process 2 into a mixture of many different brain states that correspond to many different potential experiences, and hence to the need for the added process 1 that selects for considerations of some perceivable small part of the existing mixture, which nature will then promptly either actualize or reject. This proliferation in the brain of representations of many different alternative possible immediate causes of action is assured by the structure of ion channels. Ion channels are large brain molecules, each having a small tube or channel through which ions of a particular kind, say calcium ions, can flow single file under specific brain conditions into the interior of a neuron, where they tend to cause that neuron to release in due course a vesicle of a neurotransmitter molecules into the gap that separates that neuron from a neighboring neuron. The narrowness of the ion tube ensures that the ion that enters into the interior of the neuron has a large uncertainty in its direction of motion. Hence, each ion channel in the brain is the source of a dynamical uncertainty. Uncertainty must be uncertainty in the process 2 generated evolution of the quantum state of the brain. The resulting macroscopic state of the brain will thus tend to evolve into a quantum mixture of many different classically describable brain states, each with a different perceptual correlate between which the mind-dependent quantum process 1 is free to choose. Thus, the pertinent for us essence of quantum mechanics is the causal dynamical linkage that quantum mechanics specifies between our conscious thoughts and our atomic particle-based brains. The quantum mechanically entail causal effects of our mental intentions upon our material brains is in complete harmony with our normal intuition, which is based on our lifetimes of first-hand empirical evidence. Our minds are prompted by quantum dynamics from the absurd role of impotent witnesses of events they cannot affect to causally effective instigators of intended bodily actions. Our minds thus have a natural reason to exist, which is to help us to achieve what we value, not to deceive us into believing we are something we are not. The conclusion here and in what follows is that the realistically interpreted orthodox quantum conception of reality provides not only dynamical explanations of a well-established ordinary empirical data, but automatically also the foundation of a rationally coherent dynamical understanding of how our conscious minds can affect our material brains, and hence our material bodies in ways concordant with both our conscious intentions and the empirical data of everyday life. Those ubiquitous first-hand data which seem to confirm the causal power of our mental intentions need not to be interpreted as illusions or delusions as the Newtonian particle-based materialistic physics appears to demand. Likewise, the problem of the seeming incompatibility of free will and determinism is resolved by noting that the quantum mechanical law of evolution incorporates the inputs from our free choices into the causal dynamics. Hence, there is a natural causal evolution, and thus no causal gap or incompatibility that needs to be explained. The reader might be encouraged to take von Neumann's formulation of quantum mechanics seriously by considering the words of the distinguished Nobel laureate Hans Bethe, who said, "I have sometimes wondered whether the brain like von Neumann's does not indicate a species superior to that of man." Another expression of the same idea was a joking suggestion that von Neumann was actually an outer space alien who had trained himself to perfectly imitate a human being in every way. Oh, yeah. Potentia, the central theme of the realistically interpreted orthodox quantum mechanics, being expounded in this book, is that the quantum state, i.e. density matrix, of the universe is not merely a useful pragmatic tool as proposed in the epistic Copenhagen conception of quantum mechanics, but is also a representation of essential aspects of reality itself. A basic question is then, what is the ontological character of this aspect of reality? The answer In concordance with the ideas of Heisenberg and others, it has the character of the set of Aristotelian potentialities. That is, it is a collection of potentialities or tendencies or proclivities or dispositions or probabilities for each one of a collection of alternative, possible, actual mental events to occur, each in conjunction with new, updated set of possibilities. This transformation must be actualized by a process. In the RIOQM, one such process consists of a two-phased process one probing action of the kind described in orthodox von Neumann quantum mechanics. There might conceivably be other actualization processes in the fullness of nature, but they are neither specified nor taken into consideration in this theory, which is focused on the details on the connection between our causally efficacious conscious mind and our quantum mechanically described brains. Summary. This first chapter has provided a quick overview of realistically interpreted orthodox quantum mechanics. The next 9 chapters weave into the narrative more details of the various key features of the orthodox causal connection of our minds to our brains. Chapter 11 goes a step further ontologically by arguing that the detailed behavioral properties of the various parts of the orthodox structure suggest that the mental and material aspects of reality are lodged in an overarching non-local reality that is fundamentally mind-like in character. The mental and the material aspects of the quantum dualism tend to merge. Upon detailed analysis into an underlying mental monism that includes mathematically described properties, conceived to be embedded in a 4D space-time continuum. In the end, it is indeed true that all is one, and that unity encompasses both our mental and material aspects. That idea that the underlying reality is fundamentally mind-like has been advanced often before, on the basis of all sorts of reasons, but that conclusion is often thought to involve going beyond science, and indeed going against science. Here, that conclusion arises from science-based considerations alone and nothing else. Waves, particles and minds. Sounds like a Hollywood movie to be done. Particles and waves. Classical mechanics developed during the 19th century, due principally to the work of James Clerk Maxwell, into a form that involved 2 different kinds of physical stuff: particles and waves. Electrons are the prime example of particles, whereas light in the form of the electromagnetic field is the prime example of a wave. Particles are tiny, highly localized structures, each with a center that, at each instant of time, is situated at one precise point in three-dimensional space, with the rest of the particle lying nearby. A wave, on the other hand, tends to spread out over a large region of space and to exhibit interference patterns due to the cancellations through or reinforcements of moving crests and troughs. Particles and waves have, and therefore, contradictory structures. Particles always stay tiny, whereas waves tend to spread out. Thus, Planck's discovery in 1900 that light, which had seemed to be a wave, had a corpuscular nature, came as quite a shock. Light of a given frequency appeared to be emitted in chunks, each carrying a quantity of energy that is directly proportional to the frequency of the light wave, with a universal proportionality factor called Planck's constant. Albert Einstein won the Nobel Prize for his explanation 5 years later of the photoelectric effect. Empirically, a metallic surface radiated by light of a definite frequency emits electrons with energies equal, after a correction for the energy needed to get the electron out of the metal, to the energy of the incoming quantum of light. Now understood to be localized like a particle. The concepts of classical physics were unable to cope either with this wave-particle duality problem or with a large number of other problems concerning the properties of atoms. A new way of understanding nature was needed and was created. Science and philosophy. These problems of wave-particle duality and atomic structure appears to be completely physical in nature. But the founders of quantum mechanics were men of profound philosophical bent. Niels Bohr's father was an eminent physiologist familiar with the writings of William James, and Wolfgang Pauli was the godson of the philosopher Ernst Mach. Werner Heisenberg, whose father was also a professor, was greatly influenced by the views of Bohr and Pauli. All three were strongly influenced by the view of Albert Einstein that science rests in the end on empirical findings and that our physical theories are basically human inventions that help us deal with the world known to us only via our conscious observations and experiences. Bohr, concurring, announced at the start of his 1933 book, Atomic Theory and the Description of Nature, that in physics, our problem consists in the coordination of our experiences of the external world. A few pages later, he writes, "In our description of nature, the purpose is not disclose the real essence of phenomena, but only track down as far as possible relations between the manifold aspects of our experience." In line with this viewpoint, the founders of quantum theory officially presented their theory not as what would be normally called a description of an existing and evolving material reality, as was done in classical mechanics. Their theory was offered rather as a tool that scientists have invented for making testable and useful predictions about future experiences on the basis of knowledge gleaned from prior experiences. The official position was a secure one from which Bohr could defend the theory against Einstein's objections. It was useful also for keeping students on a productive track of learning how to use the theory in practical applications and prevent them from spending their time pondering philosophical issues about which even the founders did not fully agree. Heisenberg and Pauli both devoted much time and effort trying to understand the nature of the reality lying behind the pragmatic rules. And von Neumann speaks in his discussion of the measuring process about the connection of the intellectual inner life of the individual to the circumstances which actually exists in nature. He seems very clearly to be talking about an underlying reality, not merely a pragmatic tool. The fate of classical mechanics provides a stark warning of the danger of taking initial success as tantamount to victory in the search for truth. Accordingly, the impressive empirical success of standard Copenhagen orthodox quantum mechanics have failed to convince all physicists of the real need to bring into the dynamical laws any experiential quality that is not fully specified by the material and space-time structure of the universe. Alternatives to the standard quantum mechanics have thus been proposed that are essentially in line with the precepts of materialism, which exclude from the dynamics all immaterial elements. But the theme of this book is that von Neumann's orthodox formulation of the quantum mechanics, as elucidated herein, has, by virtue of the rational coherence of its mathematical, empirical, and philosophical components, the qualifications that warrants its being regarded as an adequate putative theory of reality itself. A sine qua non of an adequate theory of reality is that it provide a rationally coherent understanding of the relationship between our conscious experiences and the associated processes occurring in our brains. The realistically interpreted orthodox quantum mechanics, described here, violates the demand of materialism that our conscious experiences have no causal power beyond what can be explained by the causal properties of matter alone. When matter consists of things being described in geometrical terms and built out of geometrical structures like Newtonian particles, and their associated energy-carrying fields. This quantum mechanical world is basically a psychophysical structure in which the causal effects of the disparate mental and atomic particle-based elements are woven together by means of von Neumann's carefully formulated quantum dynamical laws. Those laws entail that a person's material actions can be influenced in specified ways by his or her mental aspects in ways that are not fixed by the evolving material aspects of the universe alone. This understanding of standard quantum mechanics is thus fundamentally non-materialistic. Our mental aspects enter into the evolution of matter in ways not reducible to effects of matter alone. It is an understanding that is based on the word and concepts of the founders, particularly Heisenberg's and Bohr's references to the free choices of probing axes on the part of the experimenter observers and Dirac's choice of response on the part of nature, all rigorously expressed in the mathematics and words of John von Neumann. This insertion of fundamentally mental causes into our basic physical theory generates a gross violation of what had for 200 years been widely regarded as a key feature of scientific theory of reality, a feature considered to identify a proposed theory as science as opposed to non-science. Indeed, the materialist demand of strict exclusion from the material world of all effects of mental causes is still regarded as a scientific imperative by many researchers, who consequently endeavor to explain the seemingly mind-related behavior of a person's body, whilst stoutly denying the possibility of any actual causal effect of that person's mind upon his or her bodily behavior. But how did this radical break with materialism ever came about? How and why did the band of highly reputable physicists that created quantum mechanics suddenly in 1925 feel entitled to make this huge break with the then highly honored classical materialistic tradition? The answer is to be found in, I'm going to put a short break here, sorry. In Heisenberg's seminal 1925 discovery. The common idea of quantum mechanics in the minds of many non-physicists centers on Bohr's renowned model of the atom. According to that model, atoms are like miniature classical solar systems in which the circling electrons tend to stay on favored orbits, but make occasional jumps from one such orbit to another with an associated emission or absorption of a photon. That model is an essentially classical physical system, with some added quantum conditions that there exist these favored orbits, whose location are related to the mysterious quantum constant discovered in 1900 by Max Planck. Bohr's model dates from 1913 and hence was 12 years shy of the 1925 creation of quantum mechanics. While that 1913 model certainly does bring an important quantum element into the dynamics, it is seriously deficient in a characterization of the essential difference between classical mechanics and its quantum successors. It is ironic that this Bohr model of orbiting electrons is often offered as an example of the quantum nature of things, when actually the creation of quantum mechanics triggered by Heisenberg's 1925 work was precisely a rejection of the ideas of the 1913 quasi-classical Bohr model, with its definite trajectories of orbiting electrons and the lack of all reference to our knowledge. The key differences between standard Copenhagen orthodox quantum mechanics and its classical predecessors are, first, that the classical notion of particles as tiny objects moving on trajectories is replaced by the quantum notion of atomic particles represented by waves. Second, that in the new theory these particles do not have well-defined trajectories. And a third, that the needed abrupt collapses of the quantum states of systems are instigated by mental aspects of nature, not by purely mechanical material aspects of nature acting alone. Thus our conscious experiences are, according to the new orthodox view, not causally inert bystanders as in classical mechanics, but play an essential causal role in the determination of the objective psychophysical future. These differences underscore the radically new ideas that emerged from Heisenberg's 1925 discovery and that are mathematically embodied in realistically construed standard quantum mechanics. The principle of the causal closure of physical is, as mentioned earlier, sometimes regarded as a part of a definition of science, a discriminating property that sets science apart from non-science. But science is perhaps better characterized, following the leads of Galileo and Bacon, by our essential use of proving actions intended to test hypotheses and thereby allow us to acquire knowledge about the material world, coupled with our practical applications of the knowledge that we thereby acquire. Bohr's 1913 model does not bring into the dynamics any clear indication of a failure of the core precepts of materialistic classical physics. It merely adds some quantum conditions. And that model seemed to be putting physics onto a promising track. But then, how and why did this radical triad of ideas, the representation of an atomic particle by a wave, the omission of particle trajectory, and the essential incorporation into the dynamics of the non-materialistic processes of our acquiring knowledge, suddenly became accepted in 1925 by the founders of quantum mechanics as core precepts of the new physical theory. How did those completely alien and subversive ideas gain traction in a scientific environment so intrinsically hostile to them? The abrupt 1925 turnabout was instigated by the persisting failures of the semi-classical attempts to account for the accumulating data of atomic physics, and coupled with a profound discovery made in 1925 by Werner Heisenberg. He had come to believe that something was profoundly wrong with the essentially classical ideas of the 1913 Bohr model, and that the needed new theory should be built upon properties that are actually known to exist by the virtue of our capacity to become cognizant of the numerical values by performing appropriate measuring procedures. These considerations directed Heisenberg's attention to the empirical processes of acquiring knowledge. While studying theoretically the processes of measuring respectively the location and the momentum of an atomic particle, say an electron, Heisenberg found that if the location was measured first, the momentum second, then the product of the two outcomes differs from the product obtained when the true properties are measured in the reverse order. And the difference between these two products is essentially the famous constant that Planck discovered in 1900. Consequently, this completely unexpected connection between the outcomes of the two observation procedures must be connected to the quantum character of reality. And it entails that the process of acquiring knowledge about material properties cannot generally leave those properties undisturbed. For if the process of acquiring knowledge allows the observer simply to become aware of fixed pre-existing values, then the two products of the outcomes could not remain differed by the fixed Planck's constant. In the limit in which the times of the two measurements tend to become equal, Heisenberg discovered that our actions of acquiring knowledge must disturb the observed system in detailed ways that are intricately tied to Planck's constant. That discovery quickly led Heisenberg, Born, and Jordan to a radically new theory based on the idea that, in keeping with certain prevailing philosophical ideas, the core subject matter of a satisfactory theory of nature of things should be the evolving structure of our empirical knowledge of the world, not the evolving structure of an imagined material world built primarily upon Newton's solid, massy, hard, impenetrable, movable particles. Those particles can reasonably be viewed as pure fictions that happen to be useful in certain macroscopic contexts, but that fail to work in situations involving our acquiring our knowledge about the structure and behavior of atomic particles, particularly those contained in the neural brain correlates of our perceptions. The notion that the material world is built principally out of these Newtonian particles is, from the standard view of the quantum mechanics, a useful fictional creation of Isaac Newton. There exists no empirical evidence for the actual existence. Accordingly, the core subject matter of the new theory is taken to be something we do know, namely the structure of our evolving knowledge of the material world. This knowledge is asserted to be generated by the specified objective mind-brain process of acquiring subjective knowledge. This process of observation is, according to the new theory, instigated in part, just as we innately feel it is, by the observer's mental intent and conscious effort, which thereby causally affect the observed material world. Orthodox quantum mechanics spells out in great, although not complete, detail of how this mind-brain connection works. Using measuring devices to acquire knowledge about matter dates from antiquity, and telescopes and microscopes were important in the development of classical mechanics. But in quantum mechanics, Heisenberg's discovery entails that, in principle, these two processes of measurement of location and momentum cannot individually always leave the measured system just as it was, and with definite values of these two properties. For if they did, the product of the outcomes of these two knowledge acquiring operations would have to be independent of the temporal ordering of these two procedures, in the limit in which they became simultaneous. Thus, Heisenberg's 1925 discovery entails that the increases in our knowledge of the properties of matter, which we acquire by performing measurements, cannot in general leave the state of the measured matter unchanged. With definite values of these two properties, the probing processes that allow us to gain knowledge about properties of matter must in principle sometimes disturb those properties by finite, non-zero amounts specified by Planck's constant. But in classical mechanics, this difference can in principle be smaller than what quantum reality demands. Thus, in order to accommodate Heisenberg's finding about the mind-brain connection, we must, as a matter of principle, abandon classical mechanics and more generally the philosophy of materialism. The problem facing the founders was not merely to acknowledge the failure of the simple idea that we trivially acquire knowledge of the material world by simply mentally grasping directly the material facts, as was effectively assumed in classical mechanics and by neurology until James Gibson and all other subjects of human knowledge until this day, I would say. It is obvious that the fact that we can learn about the motions of the tiny pinpoints of light that correspond to planets without appreciably affecting their motions does not automatically carry over to the motions of the points that corresponds to their locations, to the locations of the electrons or atoms in our brains. The needed quantum theory had to account for the fact that the process of acquiring knowledge about the properties of the material world had to disturb the material structure in precisely the quantitative way needed to account for Heisenberg's findings. Thus, a major revision of our understanding of the mind-matter connection lies at the heart of quantum mechanics. To expect, under these conditions, to understand the mind-brain connection within the materialistic classical framework is truly an astonishing hypothesis, as was recognized by Francis Crick, who nevertheless espoused it and called for a classical physics-based neuroscience. That recommendation has dominated subsequent neuroscience and produced a plethora of data, but unsurprisingly, no understanding how our mental consciousness is connected to our material brains. This book is about the non-astonishing orthodox quantum mechanical claim that the mind-matter connection is indeed a quantum effect and nothing else. In the light of Heisenberg's discovery, the founders of quantum mechanics were emboldened to let go of classical mechanics, which effectively sets Planck's constant to zero in conflict with nature, and instead build a rationally coherent alternative to classical mechanics that incorporates into its foundational structure Heisenberg's discovery pertaining to the general, non-trivial effects of the process of acquiring subjective knowledge about the objective state of the material world, and that moreover permits precise predictions about the observed structure of human knowledge. Within this quantum framework, a person's acquired knowledge of material properties is not a faithful representation of the pre-probing properties of the observed system. Very important here. It is not a faithful representation of the pre-probing properties of the observed system. This is proved. I think that's vital to remember. This is actually proved. There's nothing astonishing about this. This has been proved for almost 1 century. The observers, uncoerced by matter choices of what to observe, affect the temporal evolution of the material aspects of nature. There it is. What can I say? One therefore cannot exclude the effects of the processes of our acquiring knowledge from an adequate basic physical theory. That effect is both limiting and liberating. It limits via the uncertainty principle what we can know, but expands via the entailed power of our minds the possibilities for what we can do. The orthodox quantum framework is therefore not just the arbitrary construct conjured out of thin air by the founders and justified merely by its eventual success in accounting for the behavior of matter. The driving endeavor of the founders was to create a rationally coherent conceptual structure that accommodates and explains and is able to make useful predictions about the structure of our conscious experiences. Our experiences thereby become the basic veridical realities of the theory, not misleading delusions. Very important. I would point it out again, it's important to understand the proof here. If there is no proof, you'll be walking on thin air, but there is a proof in the bottom. It's stepping away of that proof that had made modern science. This is going back to the origins. Heisenberg's 1925 discovery was that the process of acquiring knowledge about the material world is very non-trivial. It is not a mere grasping of pre-existing realities, but a highly structured action upon those realities. That unexpected result elevates the science-based conception of ourselves from passive observers to active agents. That reversal is the underlying core message of quantum mechanics. In the oft-cited words of Niels Bohr, in the drama of the existence we are ourselves both actors and spectators. Standard quantum theory is thus a psychophysical or perhaps an epistomaterial theory of the interaction of the evolving material aspects of nature with our evolving knowledge of those very aspects. The theory, with its detailed agreements with observed, hence macroscopic data, emerge basically from Heisenberg's guiding principle, which restricts what the theory postulates to exist, to properties of a kind that we can, via our observations, know exist. His principle was to build up an empirically secure foundation instead of empirically unsupported guesses. The close agreement of the resulting theory with the normal objective empirical data is certainly a bottom line success, but standard quantum theory describes, via process 1, also the dynamical connection between a person's mentally instigated actions and that person's consequent mental perceptions of material responses to those very actions. Any putative alternative, non-standard quantum theory that fails to provide a rational theory of these more subjective aspects of the mind-brain connection is fundamentally deficient compared to the standard quantum mechanics. It was the assumed possibility for an ideal observer to know in principle simultaneously both the location and the momentum of every particle in the universe, and eventually the analogous properties of the fields, that allowed Laplace to deduce from the materialistic principles of classical mechanics the determinism of the material world, and hence, within the framework of classical mechanics, the impossibility of a causal intervention of anything not fully characterized by its material properties. But that whole notion of the causal closure of the physical fails in a world where the mind-dependent quantum dynamical rules prevail, which is this world. I think we should round up here. Say thank you very much for your patience with Henry Stapp and with me. Have a very pleasant evening. Bye bye.